Good Friday, everybody. Thank you so much for joining us today. My name is Melody McAllister. I'm standing in for Alice as she is moving to Kansas, like she's told you probably. So she's going to be back here on Monday, so no worries. But I'm here with the awesome Tim and Chris as we talk about teaching math remotely with GeoGebra. This is part 4. If you've missed the first 3 parts, you can see the other streams. They're still there on Alice's page and on Tim's page and also on their YouTube channels. So feel free to go back and get all the other parts. But today we're going to have lots of fun. And before we start, Tim, can you tell us a little bit about yourself?
Sure. Thank you, Melody, for the introduction. The Professional Development Director at GeoGebra. Taught high school math 15 years, part-time at the college. And honestly, my passion is really helping teachers and students, just teachers in general, create student-centered learning environments active. And it can be active even in remote learning settings, as we're going to see in just a little bit today.
Awesome. Thank you, Tim. And Chris, tell us a little bit about yourself.
Hi, folks. My name's Chris Brownell. I work at Fresno Pacific University as the Director of Math and STEM Education programs. And I'm also the co-author of Math Recess, Playful Learning in an Age of Disruption. So I'm just here to have fun.
Awesome. Well, I am actually going to leave the scene and let you guys start this little webinar, but just know, and those of you watching, just put your questions below and I'll share them on the screen. And I'll also be sharing different links so that you can join us today, because today's going to be very interactive. So I'll see you in a little bit and have fun.
Okay, thank you very much, Melody. So Chris, you ready to start playing?
Let's play.
Let's play. Okay, so Math Recess play. We're going to do virtual Math Recess today. So right here, we're going to demonstrate for you GeoGebra Classroom, a brand new interface that GeoGebra has just released as of June 2nd this year. This is an interface that allows teachers to assign rich and engaging tasks for students while students are interacting and engaged in collaborative discussion or, discovery learning, things like that, the productive struggle, as we like to call it. Teachers can actually monitor and view all student progress literally in real time, as you will see on my screen today. So I cannot see the StreamYard page right now, but Melody, if you can throw the link in the chats for all the platforms that we're going through here. If you can go to this URL right here and type in that code, or if you just click on the link directly that's in the chat of the social media platform through which you're watching this, you can join this class live and literally play. We're going to role play. Everybody here is going to role play the student today of what interactive student-centered learning could look like in a 100% remote learning environment, or 50%, or whatever. So again, all I need to do is go to that classroom URL. I know Chris is in. We have Shannon, Omar, a couple people here, but let's give people a few more seconds to join. Okay, and we can get ready to get going with this class. Okay. So again, if you're just joining us for the first time here, go to the URL. It's streaming down below in the marquee pretty fast there, but that link is also posted to the social media outlets as well, and all the platforms there. Okay, so we have 4 people in. I'm sure more people will coming in. Melody, if you can keep throwing that link in maybe every 1 or 2 minutes, that would be great. Welcome, Julie. Okay, so right here, you will see this is what the teacher sees. Right now, in this activity, there are a lot of rich and engaging interactive tasks for students, ranging from kindergarten here, right? Shape identification, making change and such. Ooh, clocks, analog clock, right? All the way to measuring and up to like high school. But we are going to start in the elementary grades. Okay, so the first task is, for those of you that are in the class, would you please just start doing the first task here? I would love to see what you all come up with there, just to see what I see as a teacher, and you could see it as a student. Now, what I might recommend literally is to, if you're watching this on a computer, I might do as I'm doing here. I might open up a brand new browser window, go to geogebra.org. And I literally I'm going to go in as a student. So let me actually just make this a little bit smaller here. Okay, and I'll make this page smaller as well. Give me a second. Whenever I do webinars like this to show teacher and student view, I always have too much open here, but let's see. And if you have questions, feel free to throw them in the chat. Ooh, lots of people that are starting right here. Okay. Again, the student here. I'm going to go in as a student as well. I'm going to call myself anonymous. All right. And I'm going to role play student along with every one of you here. Okay. This is the power of GeoGebra Classroom. Yes, you are interacting, you're working, but I can see all your work in real time, and I'll show you that in just 1 second here. So let me just X that out there. Now, let's see. So in this task here, I can see the work of a lot of students already. Here we have Chris, Shannon, and for the people that are here, go ahead and for the 7 of you that are in this class so far, Igor's here, could you actually just move your shapes around a little bit? I just want you to be able to see what I can see as a teacher.
Hey, Tim.
Yeah.
I was playing with this a little bit, and my circles wouldn't move over to the right. They got blocked. What? Yeah. Mean?
Oh, I did not make that resource, actually. I just copied it and put it in this activity. So you have to take that up with the original creator of the activity.
Can you zoom in on? Can you show what I did?
Yes.
Are you able to see what
Chris,
I did?
There's your thumbnail right here, Chris, right? In fact, since we have enough students in there, let me just do this. I can actually click on Chris's work, and that's exactly as you left it, right? I mean, somehow you got the algebra view open there. I'm not sure how you did that, but you did.
I don't know how I did either. I don't
Interesting.
think I did.
Or maybe that's a workflow issue. We're still going to work out there, but that's okay. But let me go back here for a second and I look at Shannon's work. All right, didn't expect that to pop up, but again, the views, I guess that was another view there. But the thing is, here I can see, I can tell more from the thumbnails here because I can see Brenda, for example, has all the triangles moved. I could tell Igor has it too. So see, I am formatively assessing my kindergarten students here in real time, and I don't have to ask any one of them to share their screens.
So we can see just what everybody's doing at a moment's notice. I like that.
Yeah, it's like a 1 or 2 second delay, but it's every second or two it updates. Let's just skip that and go to task 2. Some of you already done it. I already know that Shannon, Brenda, and Karen already finished. Okay. And right here, you know, we have some people still in progress here. A couple people haven't started it yet. But if I go back to, as a teacher, if I go back to the overview page right up here, I now have 15 students in the class, right? And go into the task overview page, I can see how many students out of 15 in this case have started each particular task. Again, I know teachers, you're probably thinking, hey, Tim, how do I make my own class? Again, we're going to talk about that on Monday. All we're going to do today is role play. I'm going to role play the teacher and have everybody participating. You simply role play a student in a kindergarten, in a 2nd grade class, in a 3rd grade class, to give you opportunities to literally interact with these interactives, with these activity templates here. Okay. If you can go to task 3, right? Talk about a virtual, if everybody could opt to task 3, just making change the problem with the dollar, right? The original question said something like, what was it? I think Marcus paid so much money and they're asking you to make change here. I forgot what the amount was, but I should have put it in here as a question. That's my bad. But again, Shannon just joined here, but I'm literally seeing changes in real time here as you drag those coins. This is an activity that was originally authored by John Albright. I think he's from Indiana. He is an amazing GeoGebra author. I copied his activity and I modified it a little bit just to kind of make this this template here, if you will. All right. GeoGebra allows you to copy activities that are public, and you can create your own custom activities there. So if you are students in my, say, 2nd or 3rd grade class where we're learning, you know, how to make change for $1 perhaps, or whatever, you can use this exact activity template to create your own custom questions, if you will. And again, I'm just watching the show here, and again, I have my Zoom call, my Google Meet, whatever platform I'm using as a teacher in remote learning, but I'm literally seeing here changes in real time. Look at that, right?
So Pramod wants to know if you could repeat those steps again. I'm not sure which steps he's talking about, but
well, to enter the class, you have to click on the URL that Melody posted on all the social media platforms. Go to the chat of whatever platform you're on. Look for that social media. Look for that post there. It's also the same one that's scrolling too fast at the bottom of the screen there. Okay, and just you can go to that link right there. Or another way to do it, Chris, is to, I'll show you another way here, is if, whoops, wrong one. Hang on a second. If I copy this string of characters right here. So another way to do it, the easiest way is a direct link, but another way to do it here is to, let's clear out of here. Go to, as a student, go to class, go to classroom right here. Sorry about that. Teacher over here, student view over here. The student goes to classroom right here. Oh. And you can enter that class code. I'll leave it up there for a few seconds if that gets more people. And I know that scroll at the bottom, we cannot control that speed. Okay.
I think we're doing pretty well. How many? It looks like there's almost 20 people in the classroom. So let's make a little more progress. Go ahead and put that in there.
Here we go. You join, and then I typed my name in already, so that's why it brought me back. But it'll prompt you to put your name. Absolutely. So again, it doesn't matter what the grade level you teach. Doesn't matter. There are resources on GeoGebra for you that you can use to actively engage your students. Let's go to now. I want to show you another feature here with task 4. I'm not sure how many have done that yet, but this task here allows you on task 4 here. This is an example of an activity, Chris, that has feedback. Now this activity I copied and edited a little bit. John Albright was the mastermind behind this thing here with a dollar bill and everything. But I know that Karen, for example, she got it. I'm looking at her preview. She got it here. Now I can start over. This is just a preview. It won't save. But again, all student work, will be saved in this platform. A teacher can get any time here. Okay, so there's my quarter over here, right? And as a teacher, you may want to make a custom app from this, and you may want to give your students, say, 4 or 5 of these, and ask your students to form a dollar 5 different ways from coins.
Nice. I like that approach of multiple ways.
Yes.
I was wondering, can we save student work? Is that possible, or is this automatically just saved? Or
it is automatic at the moment. That's a great question, Chris. At the moment, the student work is automatically saved from the teacher's profile. Like I created this class from my GeoGebra profile, so I have access to all student work at any time. Okay. However, from the student's perspective, that is from Chris's and Shannon's and Omar's and everybody who's here, if you exit out of your browser and log in again, your work will erase. However, GeoGebra is currently under development for when you log into GeoGebra as a student and have a GeoGebra account, your work will eventually save, so you can go back to it at a later date.
So it is a coming attraction to the classroom. That there will be the ability for students to iterate and reiterate their work on a process. Yes. Exactly.
Absolutely. Yes. And so, because honestly, right now, GeoGebra really needed to get this out there because we need a mode of formative assessment that's less stressful for teachers and students. And in my opinion, this is an awesome platform to do that. Like Omar just put a bunch of coins right here. 50 cents. There's his dollar right there. I could just tell he got it without him having to screen share it to me. You know what I mean? So it's like it helps make teachers' lives easier in the remote learning setting because teachers have enough struggles and enough stressors. The fact that we are either partially remote or fully remote, it's exhausting. But this can help. I believe help with that. And so right here, how many another kind of feature GeoGebra has in activities or multiple choice or check all that apply sort of questions. So in task 5 here, if you could just humor me here, just for the heck of it, would you just check a lot of wrong answers and some right answer? There's only one right answer, obviously, but could you just go ahead for just a couple seconds and just check all and check none, I want you to watch this here. All right, go to task 5 and start clicking like crazy. Check in, check out. You see what I'm saying? Those bars, that data will come in real time. Okay, so I could see a majority of the class, selected the correct answer here, right? And I could even show the correct answer. Ooh, hey, you know what I mean? But again, the purpose of this is more for formative assessment, not so much summative,
But yesterday we were having this conversation about teaching remotely. That's one of the major shifts we need to think about, and that is shifting more towards formative assessment and away from a dependence upon only summative assessments when we're working with students.
Exactly.
Especially in a remote learning setting.
You're absolutely right, Chris. That's absolutely correct. And this is one means of which you can do it. And there's also the next task, check all that apply, where there's 2 to the n possibilities, right? You could see that. And I want to show you down here. I wouldn't show this to students, but for the teacher's convenience, from the teacher side, if you click right down at the bottom, you can see which students chose which answers, or which selections, I should say.
So
okay.
Just to reiterate, if a student logs out and returns to the classroom, they have to start over from the beginning at this point in the development of GeoGebra Classroom. Is that correct?
Right. Student work will not save at the moment. Now, if you refresh your browser window and keep the same page open, it should reload and everything should be there. If you open up a brand new window and do it, it'll think you're a new student and prompt you to type in a new name. Okay. But pretty soon, if you're logged into GeoGebra as a student, then the work will save. It's just the feature's not there yet, but this is version 1. Version 2 is in the features coming. It's going to be a lot better.
Nice.
Yeah. Yeah. So let's check out a couple of tasks here. And hey, elementary teachers, when it comes to actually asking your students to indicate what time it is, a lot of teachers, we're thinking like, shoot, if I'm teaching remotely, the only thing I can really do is ask them I give them an analog clock and have them give me the digital time. Well, no, why not? Why not actually take, I took this resource created by Anthony Orr from Hong Kong. He's an amazing GeoGebra author, unbelievably talented. I am a huge admirer of his work, and literally just took it and edited it slightly just so a teacher now can have this modifiable clock, which the slider moves it in 5-minute increments. But what time did I ask for? 7:45, I think it was, right? And so basically, nice. A quarter after, yeah. So I can see the students moving the hands of the clock every 1 or 2 seconds. All right. So Karen, again, several students have it. And if a student has, hey, Chris, I don't think that's correct. What do you think? What does quarter of mean? Oh, okay. You know what I mean?
Oh, what? Oh,
yeah.
That's what it's
exactly.
Or like that? Is that what I'm looking for?
Yeah, I think it said quarter of whatever. Yep.
Yeah, I had quarter past, huh?
Exactly. So, and there you go.
Wrong era.
And now I'm going to look at, if I go here as a teacher, I'm going to look at the original. Let's see what task 8 was. Let's see here. I'm going to go out of there for 1 second. Task 8, each square has value 1. Display the value of 339% below. Okay, well, again, this was another great resource created by Anthony Orr, but you kind of see the logic here. Again, I like to call these virtual manipulatives because you can use them in more than one way, So on Monday, on Monday and Tuesday for the little half hours, Alice, you and I have next week, we're going to show you how you can start taking these templates and creating your own custom activities for students. Okay.
I can't show 339%.
Oh, I'm sorry. Oops, I meant to say 239%. That's my faux pas. Sorry about that.
Oh, okay. So that's not just me.
No, that's my mistake. But you know what makes for a great talking point? When the teacher messes up, it's okay to admit to the class you're wrong. Just on any day I made a mistake, just pick a day that ended in Y,
Oh. You have days?
Oh, every day. Every day. All right, let's go back to the class here. Let's see. Go to my class. 29, we're getting bigger. Nice. And so now, again, equivalent fractions. Time is not going to permit for us to do everything here, but I'd like to also show teachers that you can also use GeoGebra activities within GeoGebra Classroom to watch students measure. For example, would you all please go to task number 11?
So you're not just showing us things that are appropriate strictly for kindergarten, like you started with. Here are shapes from, classify, right. Choose the triangles, sort of thing. You're giving us a little bit of a broad spectrum, right? So at this point, measuring with a ruler, that's sort of a, that's an early grades sort of task, I would say.
Yes, definitely in elementary school. This is a centimeter ruler. And again, this ruler, the original version, was created by Anthony Orr from Hong Kong. Again, an amazing GeoGebra author. And so basically, I just took the ruler, I kept the ruler, just made a few edits, and then there it is. And you'll notice that he programmed it so that the 0 goes right where a lattice point is, But I am literally watching everybody measure the hypotenuse of that 512. Well, at the 13 triangle, that right triangle there, right? But check it out. I'm watching the students measure in real time, and I can actually blow up a little bit here and see, But at any moment from the teacher perspective, Chris, one thing that's important to note is that if I click on any student's work, like say yours, for example, right? This is going to give me a preview, as it says up here. It won't be saved. I can mess with it all I want, but you're not going to see the changes. And when I reload it, you may have moved it, but it's just a preview. So it's not going to save when I go in there. You're the one that's going to be able to make the changes and save it.
Oh, so I get it now. I figured out that I can actually stretch my ruler. That is a really cool little applet that Anthony made for us.
Yes.
I was wondering how I was going to get those last several centimeters.
Yeah, and actually here, just to show you, this custom toolbar, a lot of people sometimes get intimidated by the size of the GeoGebra tools there. That's like you click one and a million of them pop down, right? But here, I put the text tool in there so you can literally just go here, and I'm just going to type in 13, right? I type the number 13 using the text tool right there, right?
Right.
And I actually can take this and just put it right where it goes. So as a student, you could do that. And so I, the teacher, could see your work. I could see you measuring, and you could take the extra second to say record that right within your virtual workspace here.
Nice. Okay.
Yeah.
I was able to figure out that I could rotate it. It was nice to see that I could also stretch it.
Yes.
The nice thing about stretching it is it didn't stretch the actual length of a centimeter. It stretched ruler, adding centimeters on. Beautiful.
Exactly. No distortion. Yep. And you can actually, by the way, you can actually zoom in and zoom out here too. If you use your mouse to scroll in, go ahead, try it. We'll see it here. You can actually zoom in really close to where the 13 hits the where the 13 mark is on the hypotenuse there. You could totally do that.
Oh, and I can
see, there you are. There you just zoomed in right there. I can see that you did. If you want to zoom in and zoom out, this particular app has that functionality. Okay, it's a lot of fun.
Okay, that is very, very cool.
So teachers, there's nothing stopping you from making segments here and asking. You could have your students discover the Pythagorean theorem, say in this way. Again, there's many ways you could have your kids discover, actively engage and explore. And then we could talk. We could build squares on top of those, like say the next day. You know what I mean? All student centered, all active.
So let me ask you this: you didn't have to make this ruler, this applet, or if you will, or
app,
application within the GeoGebra app itself was created by someone else, and these exist for teachers to go out and find. Using what we learned yesterday, how to do a Google search for GeoGebra resources, and find these things, and then bring them into a classroom and use them as a teacher might wish, right?
Exactly. And in fact, at the very end, I'm going to ask Melody to post a GeoGebra book of a lot of templates that are original versions of what a lot of other people out there have made, and some of it are just modifications of them. And there are a lot of repeats. They're just basically Monday we'll copy the activities, and then we'll create our own custom activity for students where students are actively engaged. We'll do it fairly quickly.
Nice.
Yeah, and in task 12, again, you'll see I'm asking you to use the protractor. Another virtual manipulative that was also created by Anthony Orr. If you search protractor in GeoGebra's search field, his resource will definitely come up there. I just took that. I took a few things out. I added a few angles in here for you to measure, right? And teachers, don't your students always want to go for the little protractors and never the big ones? Because when you have an angle whose rays are not long enough drawn, you know what I mean? And then you have the big fat protractor right there, and it's like, oh shoot, what does the student have to do? The student has to actually extend the ray a little bit, right? So I'm gonna, again, Shannon's not gonna see my work. I'm just using hers as a template to show. But check this out, Chris, right? I could take this protractor here. Again, you move it with the red dot here, put that on D. I know I got to move that down here, right?
Yeah.
Like that. Watch this. Now, it really looks like 90 degrees, but not quite sure. So what I'm going to do is I'm going to take it off for a second, and notice there's a ray tool here. Let's actually extend that DE to go like long all the way out. You know what I mean?
We would with
a ruler,
a real straight edge and compass, or straight edge and protractor.
Exactly. And so now we'll move this back here. Check it out. Boom. Yep. I would conjecture it. Yeah, it's a little over, but I'd say 90 is fine. You know,
pretty close. So,
yeah.
There a question came out. Erica asked the question. She tried to create her own applet to use in a class. How much customization can a teacher actually possess?
A lot. It all depends on how familiar you are with GeoGebra. Erica, there are some customizations you can do. A lot of teachers find where, for example, they find an app that they love, like this protractor one, and they just simply copy the activity with that app in it, and they'll just start asking their own questions about it. And that's easy to do. But to actually but you can also go in here and you could do your own thing. But we'll be talking about that more next week and in the weeks to come in these little half-hour tidbits we do every day. Today's agenda is just to get a feel for what a student can literally do in a remote classroom with this platform.
I think it's important to note, at least for me, that an answer to that question as well is that everything you're demonstrating today was created essentially by a teacher who dove in and made things for themselves, except for the actual GeoGebra geometry tools that you've got linked back at task 12, where there's the toolbars that are placed in there.
Yeah.
The protractor and all these activities and fixing the angles so that people measure what you're asking them to measure and that sort of thing. All of that was learned by somebody who started one day knowing nothing about GeoGebra, and they aren't necessarily created by paid GeoGebra experts.
Exactly. Teachers. I mean, it's think of when you go to YouTube, you want to, how do I fix a leaky faucet, right? You'll have videos that are made by professional plumbers, right? And then you'll have videos by someone who doesn't know really how to fix a leaky faucet, but they're going to put it up there anyway. You know what I mean?
Sometimes
but
more helpful.
Yeah, exactly. So it's just like when you're looking for things, like as I said, I think in a past session that we did, when you research resources, GeoGebra had a team of translators, even in the default languages. If you set the default language to GeoGebra as Spanish, you'll find a lot of the favorite Spanish resources that are widely used, that kind of thing, that are good. By the way, Chris, speaking of authorship, this app, I don't know if any teachers out there, if this one looks familiar to you, if any 6th grade teacher out there, recognizes this app. If you use the illustrative mathematics 6 to 8 curriculum, this app is actually in lesson, I think 6.2. It's the parallelogram lesson about talking about area. But I literally in IM 6 to 8, they have a GeoGebra page where all of these you could take and copy it and make your own activity from. Creative Commons licensing allows us to do that. But right here, I'm just watching the work that you're doing. I think the question asks you to find the area of the parallelogram, and doing that. And so you see here, I'm just watching use the students progress. See, Chris, here's the thing. It all goes back to pedagogy. Instead of me trying to, like, oh crap, I got to produce 8 million hours of YouTube videos to give it to my students. That's passive learning. But instead, take a few minutes, maybe copy something that exists, tweak it a little bit, and then have a half-hour, 45-minute class where your students are now the ones actively engaged. They're taking the driver's seat. You know what I mean? And you are formatively assessing right along with them. For this kind of modality allows teachers really to talk with students a lot more versus talking to students,
right?
Which is what direct lecture is.
Again, we're that's part of the core idea of formative assessment as well. That way you know what your student knows because you're talking to them. You're not guessing based on what they've done on a test.
Exactly. And I know our time is almost up. We were under a couple minutes. If it's okay to go 5 minutes over today, no more, I promise. But if you look right here, this was a task that I made originally, and Steve Phelps copied it, and he made it a million times better, asking a lot of way more awesome critical thinking questions than I could come up with at the time. But right here, again, algebra teachers, all the task is asking you to do is to move those points around and watch what happens to that mystery number, and the question below it, what do you notice? What do you wonder? What's going on here? You see, you algebra teachers know this is the correlation coefficient, right? But the thing is, why not actually take this, and we could take this app and copy it, say, and ask the students, well, what happens? Can you make that number R as high as possible, please? You know what I mean? What's the biggest that mystery number ever gets? With GeoGebra, you can do that. On a tip, again, on other tech devices, you have to go to a separate interface to change coordinates and go back. You know what I mean? But with, again, you see simultaneous changes in the number as you move the points. There's a lot that students can pick up. And so now I am drawing from the students. What did you notice? What did you see? I can do that in normal school, which I wish we could go back to next year, but I could also do that in a virtual setting as well.
Nice.
2 more things, and then we'll call it a day.
Yeah.
And task. Yeah.
Somebody was asking about translating some of your applets into Portuguese. I think that'd be fine, but I think she might want to speak with you directly about the ones.
Nope. Don't have to. If a resource is public, you are free to copy it at any time you want. We're going to show you how to do that more on Monday. In fact, I'll just show you right here. For example, say this coins template here. We're getting ahead of ourselves here, but see, these templates are just the same ones you work with. So you go here, you go to copy activity right there, and now you have something you can modify. Think of this as copying a Google Doc. What do you do when you have view-only access? You make a copy, you edit it to your heart's content.
There you go.
That's it. And that's all you need. Well, 2 more things, Chris, really quick. Task 16 here. You could type hello, say anything, but as you type in an open-ended response, this is an open-ended question, you will see responses come up in real time.
That is nice.
So check it out. Go ahead and start typing anything in there. Start typing a bunch of gibberish. Doesn't matter. But anything that you type will be there. And as you guys are typing stuff in, what's really cool is that you have the option to also hide the names. So if I, as a teacher, want to share my screen with my class, a student won't necessarily feel embarrassed because he or she, typed something incorrectly, say. You know what I mean? So if I hide the names, GeoGebra, makes them all, anonymize them like this, if you will. I don't know who student 30 is, and no one else in the class knows who their student 30 is except for student 30. You know what I mean? So, yeah. And let's see, where is it? Last but not least, I'd love you to take a look at, I know there's so much more I wish we could do, but task 17, and we'll end it with this. I know I'm over, we'll go. But basically, you can have your students play in 3D very easily in GeoGebra and see results here. Now, right now, there's a workflow issue in GeoGebra, but which will be fixed. But what the thumbnail, Chris, that I see is the last thing that a student touches. So if everybody touches in the 3D panel, for example, I'll see the 3D image, but that's okay for now. But just to show you what GeoGebra can do in 3D, obviously you see how we're spinning that two-dimensional entity around that line there. I can actually click on A and B. Let's bump this off the plane. And we can actually do, ladies and gentlemen, the same thing. We can get very creative digitally and do stuff digitally that, Chris, is impossible to do on paper.
This is so much better than paper.
Oh my gosh, yes. For this particular case, I agree. But you may want to ask your kids to make a simple geometric solid. Well, what do you mean by simple? Okay, well, or maybe some students, so can you make a cylinder? So if I had more time, I could ask you to perhaps make a cylinder and have everybody and have you conclude what? Oh, it has to be parallel to the line. Students are the ones making the conclusion. Students are the ones, generalizing. And so GeoGebra Classroom allows the teacher literally to basically just keep the momentum going, and while it's student centered.
Hey, Tim, it's time that we let everybody go. So do you have any ideas? What are we going to do on Monday? Will it be back in classroom and doing a few more things?
We'll show you how to create a GeoGebra class. We'll show you how to create your own classes from an activity and also from a book. So we're going to learn how to create classes on Monday, and on Tuesday we'll start creating custom activities like from others and from scratch. Super.
So everybody who's interested coming back on Monday should play around with the activities the tasks that you were given, and play around with being in a classroom and try to create your own class. But we'll teach you even more on Monday.
Definitely. And Melody, if you'd be willing to just really quickly put those two links in the final two links there. The first one is some of the templates that you played with today that you can explore. The second is an invitation to the Facebook group, Teachers Using GeoGebra. And yeah, so again, I apologize for going over a little bit, but thank you so much for joining. Have a great weekend, and we'll catch you back here on Monday.
Yeah.